Hey guys, welcome to another LeetCode tutorial. In this video, we are looking at problem number 70. This is called as climbing stairs. It is of easy difficulty and it has been asked by companies like Amazon, Apple, and Adobe. And it's one of the most frequently asked questions during an interview. Let's try and understand the problem statement here. You are climbing a staircase and it takes n steps to reach to the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top of the stairs? So this is the problem statement that we have, and the function that we are given here is climb stairs, and the parameter that we have is n, which is the number of stairs. That is the input. Okay. Now let's try and understand this concept, like how if you want to do it without writing a program. Let's try and imagine how we will be able to get to one step, right? So I'll be taking the help of a whiteboard here, and then we can start discussing about the approach. So let me use, so if n is equal to 1, and our staircase looks like this is the 0th step, and then this is the one step, right? So this is 0 and this is 1. How many ways are there for us to like climb one step? There's only one way, right? So there's one way which we'll be getting here. In one step, you'll be getting here. So when n is 1, we'll be getting there in one step, okay? And let's take another example here. When n is 2, we are going to have two staircases. And in this case, how do you get to the step number 2? That's the question. So we'll have 0, 1, and 2 as our staircase numbers. And if you look at the number of ways, you're going to start off here. So remember, we can only climb either one or two steps. So if you go with one steps, you can jump one step and then you can do another step. That's how you reach to the second step. So that means you can come in like one and one steps, right? So that's one way, by climbing one step each. And then there is another way where you can directly jump from the bottom to the second step, because climbing two steps at a time is also allowed. So that means in total there are the answer here is we have two ways to climb, and here there's only one way to climb. All right, now let's repeat this process again. If n is equal to 3, okay, now let's draw a staircase. Okay, now we have, this is 0, 1, 2, and 3. Okay, all right. So as usual, let's start off with our ones. So if I climb only one stair at a time, 1, 1, and then I'll do another one. So this is one way to get to the top of the third step. Otherwise, I can do two steps and then I can do one step. Otherwise, I can do one step and then climb two steps. Okay, so these are the possible combinations. So climbing one, let me write down the steps here. So it's 1, 1, 1, or 2, 1, or 1, 2. These are the number of steps that I can use to get to the top of third step. So there are, in total, we have 3 ways to get to the top of third step. Similarly, let's take one more example. This will be our last step, and then we can identify a pattern. So if you take n equal to 4, then 1, 2, 3, and 4, right? 3, 4. Okay. So it'll be 0, 1, 2, 3, and 4. Okay. Now, let's do this one step at a time. 1, 2, 3, and 4. So this is one way to get to the top, and the other way is going two steps at a time, and then you'll reach to the top. And the there's another way, which is to climb uh, one step, then two steps, and then one step. Okay, or you can do two steps, one step, and one step. Uh, and the last one is um, you can do one step, um, two steps, and one step. So let me actually write it down here so that it's clear. It's getting messier. Uh, so if I add my values, so I'll be 1, comma 1, comma 1, comma 1. So that is climbing each step at a time. Then I can do 1, comma, I'll get to the first step, uh, and then I can get to the next step and then do 2. Okay, or I can do one step, two steps, and then one step, or I can do two steps, one step, and one step, right? I can jump to the second step and then do one step and one step. So these are different ways. Otherwise, I can do two steps and two steps. So that will also take me to 4. Now you can see that there are in total there are five ways that I can reach to the top of my fourth step. Okay. Uh, so like if you observe this, the if when n is equal to 4, we have a total of 5 ways to reach to the top, right? But when n is 3, we have 3 ways to reach to the top. And when n is 2, we have 2 ways. When n is 1, we have 1 way. If you see, there's a pattern here. It's called recurrence. If you identify the recurrence pattern, n is equal to 4. The number of ways in which you can get to the top of n equal to 4 is that is by adding n minus 1, which is 3, plus n minus 2, which is 2. Okay, so since we have already solved number of ways, I mean, when n equal to 2, the number of ways to reach to the top of n equal to 2 is 2. And since we have already solved the problem of getting to the top of third step, all we have to do is we just need to remember these two values and then add 3 plus 2, that will be 5. You don't need to calculate all the combinations, right? So if you see, then the common steps here, there are this set of values here are already like a subset in this particular ways. If you see 1 comma 1 comma 1 is already present here, and then 2 comma 1 is already present, and all you have to do is like go for an extra step. Similarly, 1 comma 2 is also present. So this is basically we are taking and solving the smallest step, and then we are building on top of each step and trying to get to the maximum number of ways in which you can get to the top of n number of steps. So basically we are solving a sub problem and then building on top of it to find a bigger problem. So that's why this technique that we are using is called as dynamic programming, where we remember the previous steps or smaller subproblem steps and then finally get to the largest step. Okay, now I hope this is clear. You can go through it one more time if it's slightly confusing, because this is a concept which needs a lot of practice and a lot of patience to understand. Okay, and now let's try and get to the problem here. When n equal to 1, we already know that the number of ways is 1. When n equal to 2, we are having our value number of ways to get there is 2. When n is 3, we have it as 3. When n is 4, we are having the value as 5. Okay, now this also follows a Fibonacci series sequence, if you know what Fibonacci is. But let's start off with the solving the problem here. Now, what we are doing here is, if we know that our n value is less than or equal to 1 or 2, which is if n is less than or equal to 2, then we know that we just need to return n, because if it is 1, you just return 1. If it is 2, you just return 2. So that's how, if it is less than or equal to n, we return that. Now, what we are doing is we need to store, yeah, let's add this. So we need to create an array of values of, basically these are the results of our subproblems, and then that will be a new array of length n plus 1. Okay, because it starts with the index 0, so you need to create n plus 1. Now, what we are going to be doing is, we will add our first two values, which is dp of 1 equal to 1, and dp of 2 is equal to 2. So this array is representing the number of, so each index is representing n, which is the number of ways to get to the top of the n steps. And then you need to, we'll have the answer to that in the array, which is one way. These are two ways. For n equal to 3, I equal to 3, I less than or equal to n, you are going all the way till n, and then I plus plus. In this case, what you do is, you are going to assign the value of I, which is that particular index. The value will be dp of I minus 1 plus dp of I minus 2. Okay, so if it is 3, you are going to add up to the value of dp of 2 plus dp of 3, which will be 3. Okay, sorry, which will be 3. So let me just add them here. I mean, add them in a comment section. Will be 3, right? When we increment I to 4, then we know that we just need to add dp of 3, which is I minus 1, and I minus 2, which is dp of 2. That will be 5, and then that will continue. This pattern will continue for the next number of steps. So uh, whenever you hit any number, this given any number of steps with n equal to, let's say less than 45, less than or equal to 45, you can easily solve this with this technique, which is the memoization technique. So you're remembering the value within the array, as and when you are calculating it, you're also putting them into the array, and then all you have to do is you look up to the previous two values and then add them, so that it becomes a current values, number of ways to get there. Okay, now all you have to do is you just return dp of n, right? That is our, that will give us our value at the nth index within the dp array. Okay, so this is how you solve it. So let's go ahead and run this. You can see that it worked for n equal to 2 and n equal to 3. Let's also add, let me add maybe n equal to 4 and then n equal to 10. Okay, so n equal to 4, as we have already figured it out, it's 5. Okay, what's the value for n equal to 10? It's going to be 89 ways to get to the 10th step. So that's how you solve this, and the idea of storing values here and remembering them is called as memoization. I hope this is clear to you guys, and please ask any questions that you have in the comment section. I'll be happy to answer them. And if you think this was clear to you and if you like the explanation, please give it a like. I would suggest you to go through it one more time if it's not clear. And then, yeah, if you've learned something out of this, just give this video a like, subscribe to my channel, and I'll see you in the next video. Thank you.